Hi, I teach on the Applied Science course for Level 3, and one of the routes we do is looking at medical sciences and just some of the things that you could be doing during medical sciences at Applied Science. So I'm going to show you today a little demonstration that looks at one of the aspects that we cover in Applied Science. So I've got here 2 cans of Coke, Diet Coke and regular Coke. Okay, so I'm just going to pop them into this water and see what happens. Okay, there we go. So the Diet Coke, you can see, is floating, whereas the original Coke, the full sugar Coke, has sunk to the bottom of the tank. So why do you think that could be? What we actually have here is the amount of sugar found in a can of original Coke. 39 grams of sugar dissolved in that can of Coke. And that is what makes it heavier, more dense than the Diet Coke, which has about half a gram of sweetener dissolved in there instead. So that is the reason why the original Coke sinks and the Diet Coke floats. So, how does that relate to medical sciences? Well, sugar is a big problem, especially in later life. If we look at sugar, it actually has a lot of energy in it. So I'm just going to do a little demonstration to show you that sugar has a lot of energy. So what we have here is icing sugar. And I'm just going to blow a little bit of the icing sugar into the flame. Okay, so you can see there that icing sugar, and all sugar, has a lot of energy in it. Now that can obviously be great if you're doing a lot of exercise, you're running around, you're young, you're fit, you're healthy, you're eating the sugar, you're eating chocolate, drinking the full sugar Coke, and you're fine. You're enjoying life and you're young and everything's going okay. But if you carry on eating that amount of sugar as you get older, that's when we start to develop various problems. Okay, so we can test for sugar using something that you might well have heard of from school, which is the Benedict's test. So this is just a sample of glucose solution. I'm going to pop it in the test tube and add Benedict's. 2 pipettes of Benedict's. You can then heat that up and we should get fairly quickly, a colour change. Okay? So it's a colour change that shows you that glucose is present in that solution. Now, this relates really closely to a lot of work that doctors, nurses have to do looking at people's health. What we have here is a lovely urine sample. There should not be any sugar in your urine. Your body should reabsorb all the sugar and take it into your blood so that you can use that for energy. But sometimes, if you have a certain illness that's often brought on by eating too much sugar, you can develop a condition where you end up with sugar in your urine. So we're just going to test this urine sample here. So it's the same as before. I've added the urine sample and some of the Benedict solution. So then we'll just heat it up again and see if there's any sugar in it. There you go. So the colour change indicates that there is sugar in the urine. Okay? So that is something that midwives used to have to do in people's homes in the olden days. So midwives would go around to people's houses for pregnant women, and they needed to test their urine, because one of the problems people can get in pregnancy is what we call gestational diabetes. That means that they end up with sugar in their urine, and it's a bad sign. It means that something's gone wrong. So midwives used to have to take with them a little bottle of Benedict, test tube holders, and a little portable like camping stove type of thing, or use the gas stove in the person's house, and test the urine sample for sugar in the person's house. So quite a difficult task really, and that's made a lot easier these days, because now we have an alternative to the Benedict's test, which is what midwives and doctors would more commonly use now to test a sample of urine for sugar. So if we just put plenty of this in here. There we go. And we have these little sticks called Clingy Sticks. And these are a really simple way of just testing the urine sample for sugar. So they've got a little pink box on the end, and I'm just going to dip that in, leave it in there for a short time, and we have a colour change. It's gone purple, and that shows you that there is sugar in the urine. It's a much quicker, easier way of testing the urine for sugar. So the condition you have if you have sugar in your urine is diabetes, and I'm sure a lot of people will have heard of that, because you might well have family members that have got diabetes. Lots of people get it as they get older. Some people are unlucky and they get it when they're really young, they're born with it, or their body rejects the pancreas cells as they get a little bit older, and the pancreas is responsible for making an enzyme called insulin, which usually stops the sugar being in the urine and helps it to be reabsorbed into the blood. So if you eat lots of sugary food as you get older, you can't make enough insulin, and you end up with too much sugar in your blood. Your body can't deal with it, and the sugar ends up in your urine. It's a dangerous disease which lots of people suffer from as they get older, and the way to deal with it is to stay fit and healthy and not to eat too much sugar. Okay, so that is just one of the types of things that we look at on this course. There's lots and lots of practical experiments on the applied science course. We do dissections and all sorts of other practicals which you'll get to find out more about if you come to college here.
Hi, today what I'm going to show you is a very quick forensic practical. The forensic practical I'm going to show you is called forensic entomology, and entomology is the study of insects at a crime scene. So what we've got here is a body part found at a crime scene. And one thing we need to know is how long has that body part been there? Well, entomology enables us to collect what we call, or estimate, what we call a time of death, to do with the insect activity that we've got around the crime scene. So the life cycle of a fly is driven mainly by temperature. So we're going to pretend it's a nice, warm, sunny day. It's about 21 degrees centigrade. So we found a dismembered body part at a crime scene. Flies would be attracted to decay within about half an hour of death. And the adult flies will come down, they will breed, they will lay eggs, and those eggs will hatch out into maggots. And those maggots would eat the food source, and the food source is the body part. And over time, those maggots get bigger. The older they are, they get bigger. So what we can actually do at a crime scene is collect all the insect activity, and we can measure the maggots to work out how old the maggots actually are. We'd first of all collect the adults, and we would identify what species of fly they are. So we are going to presume for this case that these are blowflies. Blowflies are the ones that are attracted to flesh straight away. So we've identified them as blowflies. So now all we're going to do is collect all the maggots that we find. And we'd collect every single one, and we would measure every single one, and we would get a mean size of the maggots. So if we just take one for argument's sake, and we measure it, we would see that this maggot is about 13 millimetres long. So what we would then do is bring it to a graph. Now this graph has already got the data of how big the age of a maggot is. So we've got a growth curve here of maggots. So we would use the graph, and if this maggot on average is 13 millimetres long, we would go up the graph to the growth curve and then down, and we would work out that the maggot is just short of 4 days old. And that will give the police a really good starting point of the investigation of how long this body part has been there. We'd look at missing persons reports to see who this belongs to. And that's why forensic entomology is really important, because at the estimated time of death is the beginning of an investigation. This was just one of the things that we do in forensic science, but we do a lot of other practicals. We do physical evidence practicals, we look at fingerprinting, we look at footprinting and what that can tell us about an investigation. This is part of biological evidence, but we also do DNA profiling, we do blood presumptive testing. Now the students that do study forensic science tend to go on to university to increase their knowledge of forensic science. Quite a few of them go and do policing degrees and therefore do want to work as a forensic science within the police force. So thanks for joining us. I hope that you've got a good overview of what we do on applied science. Just want you to all keep safe, and hopefully next September when you join us, things should be back to some sort of normality. Bye.